Hi grade 8s, welcome back to another one of our video lessons. So today we're going to continue on page 110, which is geometry of 2D shapes, identify and classify triangles. Okay guys, remember from the previous sections we were doing constructions, so that's where you were required to come up with these things, draw them, make it accurate and so on. And the last section that we did on the constructions is we learned how to construct a quadrilateral, which was a parallelogram. Remember, the parallelogram had two pairs of parallel and opposite sides. Okay, and how did we construct that? Well, we did a triangle with one of the angles, and then we measured the alternate angles from each side, and we recreated those angles and managed to draw the rest of our parallelogram. Okay. So now we're going to continue on page 110, identify and classify triangles. So I'm going to run through the theory of these triangles of things that we've gone over already. We're going to summarize it. There's a nice summary on the next page. I'll work with you through that, and we'll get onto the next page, which is 112. It has a worked example. I'll work through that with you, and you guys are going to do exercise 11.1. All right, cool. So let's start on page 110. So it says identify and classify triangles. A triangle is a three-sided polygon. You can classify triangles according to the number of equal sides they have. Okay, so remember, we've done this before. So there are three types of triangles. Well, we can have where no sides are equal. We can have where there are two sides equal. And we can have a triangle where there are three sides equal. Okay, guys, so there's only really three types of triangles. And also we have a right angle triangle, but it can also be an isosceles or a scalene and so on. Okay, so a scalene triangle is a triangle which has all different sides. Okay, so the lengths of all the sides is different, which means now that the angles will also be all different. Okay. Then the next triangle we have is an isosceles triangle where we only have two of the three sides that are equal. Now the thing with the isosceles triangle is that the, the angles opposite the sides are equal. So if these two sides are equal, it means that this angle and this angle are also equal. Okay, so that's our isosceles triangle. And our equilateral triangle is the triangle that has all three sides the same, which means all three angles are the same. How much are those angles? Well, angles of a triangle add up to 180. 180 divided by 3 gives us a 60. So if we have an equilateral triangle, each angle is going to be 60 degrees. If we have an isosceles triangle, we don't know what the angles are because we don't have any sizes here. Okay, but if they give us any one of these, we can always work out the rest. Because if I say, well, this angle is 50, that means this angle is also 50. That means together they are 100. That only leaves 80 for the other one. And if I give you the other one, I say this one is 80, work out what these two are. Well, total is 180. I take away the 80, leaves me with 100. I have two of the same angles, so the 100 needs to divide equally into the two parts. So 100 divided by 2 will give me 50 degrees. Okay. So guys, that's the three main types of the triangles that we do have. Okay, and they're on page 110 in the diagram there. Okay. There's a close relationship between the sides of triangles and the sizes of their interior angles. You can classify triangles by looking at the size of their largest angles. You learned about the classifications of different angles in topic 10. Refer to page 95 to refresh your memory. All right, so now I'm sure you've heard of things like an acute triangle, an obtuse triangle, a right angle triangle. So those are classifications of triangles of the largest angle in the triangle. Okay, so let's say I have a triangle that looks like this, right? It's almost an equilateral. Let's say this is 50, this is 60, and this is 70. Okay, my largest angle is 70 degrees. Okay, so and that angle of 70 is an acute angle, which means that this is an acute triangle. Okay, if I have a right angle triangle like that, okay, let's say this is 90 and this is 45 and 45. Okay, it's an isosceles triangle. What kind of triangle is it? It's a right angle triangle. Why? Because the biggest angle is 90, and we call 90 a right angle triangle. Okay. Right, and then the last the last triangle we have is an obtuse triangle. So it's something that looks like this. Okay. Here we have an angle which is greater than 90. You can see it goes past the vertical 90. So let's say this is 120 degrees. And this is 30 degrees, and that's 50 degrees. Okay. So the largest angle in this triangle is 120 degrees, and it's an obtuse angle, which means that this is an obtuse triangle. Okay. Or an obtuse angled triangle. All right, guys, so remember, it's the biggest angle in the triangle that will classify that triangle as whatever it is. And remember, we can still have scalene, isosceles, and equilateral. So these classifications come on top of the ones that we already have. Okay. Right, let's see what they say in the Did You Know box. The word geometry is derived from the ancient Greek language. Geo means earth, and metron means measurement. So really, geometry means measuring the earth. Okay, I didn't know that. That's quite interesting. Right, let's go to the next page. So now we have classifications of triangles based on their sides and angles. Okay, so let's go through each one. So first we have a scaling triangle. Properties: no equal sides, no equal angles. Okay. An acute angle triangle, 3 acute angles. So there is an example of a acute angle triangle. Then we have a right angle triangle, which is also a scalene. And we have an obtuse angle triangle, which is also scalene. Does that make sense? So we can have all these triangles with different sizes of sides, but different angles, and given those angles, we can classify them differently, whether acute, obtuse, or right angle. Okay, now we have an isosceles triangle. Isosceles has 2 equal sides, 2 equal angles. Can we have an acute angled isosceles triangle? Yes, there's an example. Biggest angle, 76 degrees. Can we have a right angled isosceles triangle? Yes, we can. I actually drew one earlier on the board, which was the 90-degree isosceles triangle. And then the next one is obtuse angle triangle. Yes, our biggest angle just needs to be greater than 90 degrees, and we have our obtuse angle triangle. All right, what you're noticing there is that each one of those triangles in the isosceles row has those 2 blue markings, meaning that the sides are the same. Okay, remember that's what classified our isosceles triangle. All right, and then the next one is an equilateral triangle. An equilateral triangle can only be an acute angle triangle. Why? Because the specific thing about an equilateral triangle is that all sides are equal and all angles are equal. So the biggest size angle we can have is 60, which is really the only size angle we can have, because 180 divides by 3 and we get an answer of 60. We can't have an angle of 50, 50, 50 because that doesn't add up to 180. We're missing 30 degrees. Okay. So an equilateral triangle is only an acute angle triangle with equal sides and equal angles. Okay. Cool. Let's continue. Then we have triangle identification. Sides: 3 equal sides, equilateral triangle. 2 equal sides, isosceles. No equal sides, it's a scalene. Angles: 3 equal angles, equilateral. 2 equal angles, isosceles. No equal angles, scalene. 1 obtuse angle, an obtuse angle triangle. 1 right angle, or right angle triangle. 3 acute angles, acute angle triangle. So guys, again, there's a nice summary of all the types of triangles that we can deal with. There they are. So the best classification of a triangle takes both its sides and angles into account. If a triangle has 2 equal sides and a right angle, it is a right-angled isosceles triangle. If a triangle has 2 equal sides and an obtuse angle, it is an obtuse-angled isosceles triangle. Okay, so all we're doing here is we're combining both of the classifications to give the reader or whoever we're teaching or talking to a better understanding of what kind of triangle we are dealing with. Okay. If a triangle has 3 acute angles, it is an acute angled triangle. Did you know the sum of the interior angles of a triangle is equal to 180? So the largest angle in the triangle must be less than 180 degrees. Okay. So they're basically telling us that if we want to make a biggest obtuse angle triangle that we can, our biggest angle has to be just under 180 degrees. Okay, so remember 180 degrees is a straight line. So I'm going to not draw a straight line. I'm going to bend it up a bit. So I'm going to bend it up just a tiny bit over there. Okay, so that this angle here, let's call it 189 degrees. Okay, for argument's sake. Okay, obviously 189 degrees would be a lot flatter and you wouldn't even see what I'm trying to draw here. But let's say it's 189 degrees. Then to make a triangle, we have to join these two sides together. Okay, so we have this angle here, we have this angle here, and we have this big angle there. So this is the biggest obtuse triangle we can draw, so to speak, because 189 degrees is here. That leaves us only 1 degree on both sides. So it's half a degree on each side that we have. Okay, and if we open this thing even flatter down, what we're going to get is a straight line, because then if this angle is not 189, 179 here. If this thing is a straight line, then this joining line will coincide with that exact line and means that we won't have a triangle. So a triangle needs to have 3 angles and 3 sides. All right, cool. So again, the biggest angle you can have in a triangle has to be just below 180 degrees. Okay. Right, guys, let's continue. So we're on page 112. I'm going to run through the worked example, and you guys are going to do the exercise. So consider each statement carefully and state whether it is true or false. Give reasons for your answer. So number 1. If triangle ABC has angle A equal to angle B equals to 100 degrees, is it an obtuse angled isosceles triangle? Okay, so they're saying that there's 2 angles, A and B, in a triangle that are both 100. Okay, can we have that situation? The answer is no, because if we add all the angles in a triangle, the maximum we can ever get is 180. So these two angles that they've given us are each 100. So if we just add those two, we are already over 180 by 20. So it gives us a total of 200. So no, it's false. We can't have a triangle with 2 angles that are 100 degrees each. Number 2, a triangle cannot have a reflex angle. Okay, so let's think about that. Here's my triangle. Remember, angles, the interior angles are these angles here. Okay, an exterior angle is if we continue a particular line, and that would be the angle between the line and the triangle. Okay, there's the exterior. Can we have a reflex angle? Reflex angle has to be greater than 180 degrees. Okay, well, I think we can, because if we look at this point over here, this here is a reflex angle. Yes, okay. I mean, obviously we can't have a reflex angle inside the triangle, okay, but we can definitely have one outside of the triangle. Okay, let's actually think about it. Could we have a reflex angle outside of the triangle? Yes, okay, so that would be it. All right, so number 3. So what they're saying here is that for number 2, they say true, the triangle cannot have a reflex angle. Okay, if we go back to our classifications, a reflex angle, let's just see what they say. A reflex angle is defined as an angle between 180 and 360. Okay, between 180 and 360, therefore a triangle inside cannot have a reflex angle. But outside, we could have a reflex angle over there. But I think they're referring to the angles of the triangle being inside of the triangle. Since remember, all the angles add up to 180, we can't have one angle being more than 180 because it takes up the whole total. All right, number 3, if triangle PQR has P equals 50 and Q equals to 65, is it an acute angled scalene triangle? All right, well, 50 and 65, well, we can find the other angle. 180 minus 50 is going to be 130. 130 minus 65 is going to give us 65. Okay, so two of the angles are the same. They are saying, is it an acute angled scalene triangle? It's acute angled, but it's not scalene because two of the angles are the same, which means two of the sides are the same. So number 3 is false. Number 4, if triangle DEF has D equals 63 degrees and E equal 27 degrees, is it an acute angled scalene triangle? Okay, again, let's work out the other angle. 63 plus 27 gives us exactly 90 degrees, okay? Which means that the other angle has to be 180 minus 90, which is 90, okay? Which is a right angle triangle. So, is it an acute angled scalene triangle? No, it's not an acute angled, it's a right angle scalene triangle. Why is it scalene? Because no angles are equal to each other, which means no sides are equal to each other. Okay. Right, guys, so I'm going to leave it here. I want you to answer 11.1. That's classifying your triangles. So it's pretty much what we've been doing. The worked example underneath classifying triangles will take you through exactly the same exercise as we did on the previous page. So I'm not going to go through that. You can have a look at it if you want to. If you can't figure it out, but it's pretty straightforward. Okay, so let me do one for you so that you don't get stuck. So it says, example, classify each of these triangles based on the given information. Give reasons for your answer. So I'm looking at the green triangle. The green triangle, I can see that all angles are different, okay, which means that it's a scalene triangle. There's no sides are the same, okay. Then I look at the biggest angle. The biggest angle is 108 degrees. So it's an obtuse angle. So this triangle, ABC, is an obtuse scalene triangle or obtuse angled scalene triangle. Okay. And the reason for that, you can state that while A is greater than 90 to make it obtuse, and scalene means that no sides are the same. So say that no sides are equal as your reason, as they have said it, no equal angles or sides, it's the same. Right, guys, the rest are exactly the same things. You have to look at the info given and judge it the best you can and give me a classification. So 11.1 looks at exactly that. So guys, get 11.1 done for homework, and I will continue on page 114 in our next lesson. Okay, cool, guys. Thank you very much. I hope you enjoyed it, and I'll see you next time.